Hello everyone, here is the step-by-step explanation of my project. So initially, the script imports the module for CSV handlings, HTTP requests, data processing, and timing and the OS operations. So here on the second point, the NVD API key is set for the fetching the data from the National Vulnerability Databases. As we all know that NVD has given the 4 different versions of CVSS. So CVSS 2, CVSS 3.0, CVSS 3.1 and CVSS 4. Since CVSS 4 version is a new standard and many of the CVEs in NVD may not yet have a CVSS score, here the weightage has been assigned based on the typical metric definitions and the scoring from the first org and the open source CVSS version 4 implementations part. And based upon this weights, standard industrial weights that have been given, the calculation of CVSS 4 has been calculated and it will going to provide the exploitability and the impact. So under this particular function, get NVD detail, so it will going to gather the complete CVSS code detail based upon the type of the version. It will going to calculate, it will going to get the detail like CVSS score, CVSS severity, vector strings, exploitability scores, and the impact scores. Under this normalization helper function, this converts the raw score to 0 to 1 scale and it also handles the missing and invalid data gracefully. And under the load CSA KVE, it fetches the latest known exploit vulnerability from CISA. Here get EPSS score function. It queries the EPSS API to get the probability of exploit scores. Under the search GitHub exploits, it checks if the public exploit course is available on the GitHub and returns yes or no flag and also the counts of repositories that have been identified. During the process of the CVE, here it iterates over the CVEs in the input CSV file. For each CVE, it retrieves the EPSS score, NVD details, GitHub exploits, KEV status. And along with identification of this exploitation evidences, it also provides the exploit weightage based on KEV and the GitHub data. Here the exploit weightage accounts for the real world exploit evidences which complements the technical CVSS scores. The assigned weights has been given as 1, 0.7, 0.4 and 0 prioritizes the CVE that are more likely to exploit in practice, reflecting the actual threat likelihood beyond the theoretical CVSS. And then the normalization for the exploitability, impact, EPSS and the exploitation has been provided. Here the normalization is a standard practice to combine the metrics with the different scales. So normalizing 0 to 1 ensures the fair contribution in weighted calculation and avoid the dominancy by large scale metrics. The normalizing the exploitability score for 0 to 8.22 and the impact score 0 to 7.52. This CVSS numerical ranges are defined by the CVSS specification first.org. EPSS score, which is being scaled between 0 to 1, and the exploitation, that is an active exploitations, are based upon the presence of KEV or the GitHub repositories. Exploit likelihood calculation combines the technical exploitability, EPSS probability, and the real world evidences into a single likelihood. Here the 40% CVXS exploitation has been given, which reflects the inherent technical ease of exploitation. 40% for the EPSS has been given, which accounts for the statistical likelihood for historical data. And 20% for the KEV or the GitHub evidences, which captures the confirmed active exploits, which this particular formula balances the technical severity with the real world exploitation evidences. And once it finds out the exploit likelihood, it calculates with the impact and provides the R direct, that is a risk score of it. So once the risk score has been identified, based upon the risk score, it will going to provide the ranking systems. And at the end point, it will going to evaluate. It says that what is the correlation between the R direct, that is the risk score, and the EPSs. So under the main execution step here, it will take the input data, it deduplicates the inputs, and process the CVE, calculates and provides the ranking to it. So here is the input data which is providing, which is by having a few of the duplicate CVEs. So once the input data has been added to here, it calculates uh, for each and every CVEs and identifies the complete detail and process and provides the ranking and data. And it also evaluate what is the execution time and the correlations between the risk score and the EPSs. And here is the CVE ranked data, the CVE output CVE ranked CSV file. Where it will going to provide all the CVE details that has been identified, removing the duplicates, identify the EPSS score, EPSS percentiles, CSV based scores, where here we can see all of them are stating upon 9.8, which is our problem statement, where the severities looks to be a same and all are coming under the critical one, which one need to be prioritized, patched earlier. So here it will identify the CVSS base, and also it will checks for the exploitability score and the impact score, identifies if there is any active exploitation that is going on, uh, or is there any GitHub exploits are available, and based upon that GitHub availability, it will also checks for the GitHub exploit counts, gathers the exploit likelihood and the R direct, and provides the ranking of each of the CVEs. Thank you.